Now we can take the preceding back to the very beginning. If this is a graph of y equals 5 sine of theta, which is then raised 20 units to get the graph of y equals 5 sine of theta plus 20, to get the graph of y equals 5 sine of theta, we could have started with a circle of radius 5, constructed the graph. If we go all the way back to the very first principle, the idea that we start with a unit circle, and it's not always convenient. If you have big numbers here, 5,000 instead of 5, it's not convenient to try to visualize the unit circle, but in this case we can. So let's just think of where we are. We start with a unit circle. We use points around the unit circle, subdivide it, whatever. Identify theta with the arc distance around the circle, giving us the angle in radians. We construct the graph of just y equals plain old sine of theta. Then we use that graph, moving each point 5 times further from the y-axis to get the graph of y equals 5 sine of theta. So that y equals 5 sine of theta each point is 5 times I'll say this. Each point is 5 times further from the y-axis relative to y equals sine theta. So that should be fairly clear. This point, we have to take it 5 times further from the y-axis to get this point. This point here, we have to take it 5 times further from the y-axis to get the point lying directly above it. Then, of course, we move each point up 20 units to get this graph. So we start with our unit graph of y equals sine theta, and taking each point 5 times further from the, and I said from the y-axis, I should say from the theta axis. Taking each point 5 times further from the theta axis, we essentially stretch the graph in the vertical direction by a factor of 5. Now my statement, moving it 5 times further from the theta axis, and I would have to qualify that on the same side of the axis. So we don't take this point down here and move it 5 times further by moving it up here. Although that would satisfy the statement that we move it 5 times further, it's clear implicitly that we're going to move it on the same side of the axis. Okay, so if it's below the axis, it's going to move 5 times further below. If it's above the axis, it'll move 5 times further in the upward direction. That's called a vertical stretch. So we vertically stretch y equals sine theta by factor 5, then vertically shift (20 units in this case).